We're still working on solving systems of linear equations. This video is going to focus on solving by graphing. Okay, so we're solving systems of linear equations, which means that we're finding a point that will make both of the equations true. Okay, so the solution will be a point, and the point must be given as an ordered pair. Remember, an ordered pair is when you have both your x value and your y value, and we notate that with parentheses around it. I would suggest that you check your solutions. Again, you can do that by substituting into both equations, and if your equation or if your solution works, you will have that both sides of your equation is true, like that your equation is actually true. Okay, so we're focusing on graphing this time. So we're going to graph both equations on the same coordinate plane, and then you're going to look for the point of intersection. The intersection point would be the solution to the system of equations, because it would be the one point that makes both equations true. So if we're graphing, you can see that these are both given to you in slope-intercept form. Okay, so if I want to graph 4x plus 3, y equals 4x plus 3 on a coordinate plane, I'm going to start by plotting my y-intercept. So my y-intercept is going to be at positive 3. And then my slope is 4. So remember, this 4 means a rise over run, so 4 over 1. And so I would go up 4 and to the right 1, but I don't have room to do that. So I can go down 4 and to the left 1. Remember, we're reversing both directions. So if I do that, I'm going to go down 4, 1, 2, 3, 4, and to the left 1. And I would put a dot right there, and then I'm going to go down 4 again, 1, 2, 3, 4, and to the left 1. So I will have an ordered pair right here. So if I want to graph this line, I'm going to draw a line through these ordered pairs, and it would look something very similar to this. Okay, so my second equation is y equals negative x minus 2. So again, I start by plotting my y-intercept. My y-intercept is at negative 2. And then my slope is a negative 1. So I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So I'm going to draw a line through these points. So if I draw a line through these points, it would look very similar to this. Okay, so my solution is where the 2 points intersect. So my solution is right here, that ordered pair right here. So my ordered pair there is my x value is at negative 1, my y value is at negative 1. So the ordered pair negative 1, negative 1 would be my solution. Now I can check my solution by substituting it into my equations. If I do that, I use my first equation. I'm going to say 4 times negative 1 plus 3, and that should equal negative 1. So 4 times negative 1 is negative 4, and negative 4 plus 3 is indeed negative 1. So negative 1 equals negative 1, and I am correct. And then if I do the same thing for my second equation, I have negative 1 is equal to, now this is important, you've got a negative here, and you have a negative 1 here. So my x is a negative 1, so I have the opposite of negative 1 minus 2. I'm still substituting a negative 1 for x, even though I already have a negative in front of that. So I would read that as y is equal to the opposite of negative 1 minus 2. Now the opposite of negative 1 is positive 1. Minus 2 is indeed negative 1. So again, I have that negative 1 equals negative 1. So I know my solution is true. So my ordered pair would be at negative 1, negative 1. Okay, if I look at my second equation here, or my second set of equations, I've got y equals 1/3 x minus 3 and y equals negative x plus 1. So I need to graph both of those on the same coordinate plane. Again, these are both given to you as slope-intercept, in slope-intercept form, so they're pretty easy to graph. So I'm going to start by plotting my first equation, or my first equation. So I have y equals 1/3 x minus 3. I'm going to plot my y-intercept at negative 3. And then my slope is 1/3, which means I'm going to go up 1 and to the right 3. So up 1 and to the right 3. 1, 2, 3. And then if I just want another ordered pair in here, I could go back to my negative 3 and go down 1 and to the left 3. 1, 2, 3. Okay, so if I draw a line through these points, it would look very similar to, that's not a very good line. It's hard to draw a line using this technology. I apologize. Okay, so my second equation is at negative 1 plus x. So y equals negative, y equals negative x plus 1. So I'm going to plot my first point at 1. My slope is negative 1, so I'm going to go down 1 into the right 1, and 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 then draw a line through. Okay, so I can see that my solution is where my ordered pairs, or where my lines intersect. So my solution is right here. And the x value for that point is a positive 3, and my y value is a negative 2. So my ordered pair would be 3, negative 2. Now I would want to verify my answers by substituting it back into my equations. If I do that, I've got that negative 2 is equal to 1/3 times 3 minus 3. So negative 2 is equal to 1/3 of 3. The 3's cancel and I'm left with just 1 minus 3. So negative 2 equals negative 2, so that works. Okay, in my second equation, I've got, and we'll do it over here, negative 2 is equal to negative 3 plus 1. So negative 2 is equal to, negative 3 plus 1 is negative 2, so that also works. So I know that my solution is a good solution.